Alright, welcome everyone to my first video for this school year. We're going to talk about variables and expressions. Our objective today is to write linear equations in two variables given in a table of values, graph, and a variable description. Actually, let me rephrase that. These are the actual, say, knowledge and skills from the state. What we're going to focus on is being able to write linear expressions or equations using a verbal description. That's why I have that underlined. We also want to create and use representations to organize, record, and communicate mathematical ideas. So the big thing here is we're going to be writing verbal descriptions and communicating mathematical ideas. Oh, no, sounds crazy. Y'all can communicate in math. I know. But the idea here is that you're going to be translating. Think of it like that. Okay? So there are some vocabulary that we need to go over. If at any time you need to stop this video, pause it, just pause it. So like right now I'm about to show you like quite a few vocabulary words. I would just pause it. I will talk, but I mean you may not have enough time, so you could always pause. Anyways, here's the vocabulary. Boom, it's like magic. First one is algebraic expression. We are going to, what is an algebraic expression? It's a combination or consists of sums and products of numbers and variables. Basically, like when we see like a little strip that says like say 3x plus 4, that's an algebraic expression. The variables, don't call them letters anymore. They're variables. They're symbols used to represent unspecified numbers and values. So when you see like a variable, that's basically saying there's a number that it represents. You just don't know what that number is yet. A term is a number, a variable, or the product or quotient of a number and a variable. So like if you were to see something like say this, where you say 2x plus 4, there's a term. Notice that that's a product of a number and a variable, and there's another term, just the number itself. So this expression right here has two different terms. Okay? So just to kind of give you an idea how that, and you're going to hear me use this kind of language a lot. You need to get used to the academic vocabulary. Can't always talk like you're kind and like, I don't know, a little not very smart. Okay, got to be, consistent with this. Next vocabulary terms, we got factors. Those are the quantities being multiplied. So like when you see like that 2x, the 2 and the x were factors. They were being multiplied. The answer that you would have gotten from that is called the product. A power is an expression like x to the n, like raised to the n. So basically that whole thing, but we'll usually say like x to the n power or something like that. The exponent is that little number, which indicates the number of times the base is used as a factor, and the base is the big number in a power. The one at the bottom, that's the one that you're repeating. That one's the factor. Okay, so let's look at some examples. These aren't very hard, and this should be fairly easy. We're going to start off with this one. I see a 3, an x, and a little 4. Well, what does that mean? If I were to write that out, just like the way I would say it, that would be 3 times x to the 4th power. Okay, you could write in there 3 times x raised to the 4th power or anything like that. Keep in mind, I know that this is just x to the 4th power like this because I didn't say the product of 3x raised to the 4th power. Like, if I had said the product of 3 and x raised to the 4th power, that would have been like separating and saying the 4th power, like it would have been parentheses. So kind of keep that in mind. We're not going to make that too difficult to understand, to translate. Here's another one, just as it would read it, 5 times z raised to the 2nd power plus 16. Or to the 2nd power plus 16. So again, these shouldn't be that difficult. If you do feel like they're a little bit difficult, or if I'm going too fast, pause the video, rewind the video, and kind of let me know. On this one, let's go ahead and say, give you a second. Pause the video right now. No, I'm just kidding. But try to give yourself a few seconds to answer this. So pause the video and then give yourself a few seconds to answer. So hopefully after that pause, because hopefully you did pause, the answer would be, boom, 1/2 of a plus the product of 6 and b divided by 7. Notice there, I went ahead just to make sure you note that I want this 7 dividing the product, which means I want the 6b being done with it, or like together first. I mean, in order of operations, it would have done anyway, but I just wanted to kind of see how you see the wording. All right, so how about now we go the other way? Let's see, there's an expression that says a number t more than 6. Okay, so how do I rewrite that? Well, more than means plus, so I could do a plus symbol. Technically, and I only want you to get used to this, it wouldn't matter with plus, but I want y'all to get used to this. When you see, like, say, a joiner like that, than, more than, less than, take whatever's in front of that phrase and put it at the end, and whatever's after the phrase, put it at the beginning. Switch them. It's going to be really important for when we do less than because of the minus. Okay? So keep that in mind. Speaking of 10 less than the product of 7 and f. So here, like, this is my example, what I mean. Because with subtraction, it's very important. Minus goes there. The 10, which is in front, will go after the minus, but the product of 7 and f, that right there, will go in front of the minus. So kind of like they switch around. And there's your expression. All right, so last example, 2/3 of the volume V. Not that difficult. You just got to do this. You say 2/3, 2 divided by 3 of V. Or you could write 2V divided by 3. Oopsie, don't mean to do that. So there you go. So that's pretty much it. All right, so here I copied this from the book. It was page 6. You could easily pull that up in your student textbook if you wanted to look at it. Keep in mind, and I'm going to make note of this, don't forget, if you log into your student textbook, click on this right here. You would go to where they have what they call private tutors, and they will have people that go over these same examples in their own words, and they're specific. And for those of you that would rather hear it in Spanish, in Español, then that would be the place to go because they do them and also in Spanish. All right, so let's look at this problem. Up here, Mr. Martinez ordered 250 keychains printed with his athletic team's logo and 500 pencils printed with their web address. Write an algebraic expression that represents the cost of the order. Okay, so this one's very easy. They already have the answer, but let's look at the reasoning why. Okay, we've got the 250, and we know they're keychains. So I put a K representing the keychain, so 250K. Plus, I'm ordering also 500 pencils, so 500, and I'm going to let P represent pencils. So that way I know I'm ordering 250, and whatever the cost is of the keychains, I can multiply, put that cost in place of the K. Or the cost of the pencils, put the cost in place of the pencils. So looking at something similar, let's look at number 3. Katie bakes 40 pastries and makes coffee for 200 people. Write an algebraic expression to represent the cost of the situation. All right, so Katie bakes 40 pastries. Okay, so I'm going to write 40, and I'm going to put P for pastries. She also made coffee for 200 people, so that would add. And notice, and usually would mean that you're adding. Okay, 200, and oh wait, I can't use another P again because I've got 400P for pastries. I can't use P for people. Well, let's look. What is she making that? What is she doing for those people? She's making them coffee. So I could always use C. If you didn't, you can use any other symbol. I mean, honestly, if you wanted to say 40 smiley face plus 200 wide-eye face, you could. 40 question mark plus 200 exclamation point, that's okay. I mean, the idea here is that you're using symbols. Most likely what we use will be variables, but variables are just symbols. Okay? That's pretty much it for variable expressions. I kept it under 10 minutes, so there you go. That's my general goal, but if you do have any questions, feel free to ask. Make sure you've written them down and ask in class. That's it for today. Thank you very much.